let R of t be a vector valued function, which is 3 times differentiable, meaning that all of the components are individually 3 times differentiable. So R of t is x of t, y of t, z of t, and x triple prime, y triple prime, and z triple prime all exist. And this vector, if I take the word exist out, this vector is R triple prime. So we would like to use the product rule for the dot product and the product rule for the cross product to show that the derivative of the scalar triple product of R with R prime and R double prime, so R dot the cross product of R prime and R double prime, is the scalar triple product of R with R prime and R triple prime. So R dot the cross product of R prime cross R triple prime. Okay, so let's get to it. I think we're going to use the derivative of the dot product first, because we have a dot product here of 2 vectors, and the second vector has a complicated form. So when it comes to differentiating this one in the product rule for the dot product, we will be using the product rule for the cross product. So let's recall those rules. The derivative of a cross product, R1 of t, vector valued function, dot R2 of t, is R1 prime dotted with R2 plus the reverse, R1 dotted with R2 prime. And the cross product derivative formula is the same with a cross product. So the derivative of R1, that was supposed to be an arrow, not a prime, cross R2 is R1 cross R2 plus, R1 prime cross R2 plus R2, I like to keep the 1 and the 2 in the same order. R1 cross R2 prime. R1 prime cross R2 plus R1 cross R2 prime. Okay, so these are very nice product rules because they look just like the ordinary product rule for a function of a single variable. Now in our computation, we're also going to use the fact that if u and v are orthogonal, then that means that u dot v is equal to 0. And if u and v are parallel, that means that u cross v is the 0 vector. Okay, so let's begin our derivative here and see what happens. The derivative of the scalar triple product. We have 3 components. There are 2 different products, and the result is a scalar because this is a vector dotted with a vector. So it's called the scalar triple product. So we want the derivative of R dotted with, and for our other 2 vectors, we're going to be taking R prime cross R double prime. Okay, use the derivative of a scalar product, the derivative of the dot product. This is equal to, we have R prime dotted with the same vector here, R prime cross R double prime, and then plus R dotted with, and then we need the derivative of this guy, the derivative of number 2 here. So let's insert a differentiation operator, d over dt. And then r prime cross r double prime. Okay, now here's where we use our first fact that orthogonal vectors are give a dot product of 0. And we're going to need another fact here that u cross v is perpendicular to both u and v. So here we have r prime, which is the same as this vector, being crossed with another vector. So the resulting vector here is perpendicular to both of these. In particular, it's perpendicular to r prime of t. So that's the perpendicular symbol there, perpendicular to r prime. And here we are dotting it with r prime. So r prime dotted with a vector that's perpendicular to itself is 0, the scalar 0. So this whole part becomes 0, and we're left with r of t dotted with, and now we need this derivative. So the derivative of r prime cross r double prime. Now there is a formula for the derivative of a vector crossed with its derivative, and that formula is the first vector crossed with the derivative of the second vector. And the derivative of r double prime is r triple prime. And so that's going to immediately give us the result. But let's just go ahead and calculate this derivative and basically recreate that other rule. So all of these r's have arrows over them. There have been so many symbols to write here that I've stopped writing all the arrows, but these are all the vector valued function r of t. So r of t dotted with, and now we want this derivative, and we'll use the product rule for the cross product, and that gives us, we take r double prime, the derivative of this one, so that's r double prime cross itself, and that's going to be the 0 vector because those are parallel, and then plus r prime crossed with the derivative of this one, r prime crossed r prime of t crossed with the derivative of this one, which will be r triple prime. And these two vectors are identical and therefore parallel, and so the cross product is the 0 vector. The 0 vector plus another vector is just this other vector, and so we get the final answer. We have r of t dotted with r prime cross r triple prime as claimed. So there's our derivative of a very special scalar triple product. It's the scalar triple product of r with r prime and r double prime. And we get the scalar triple product of r with r prime and r triple prime.